All right, let's look at the homework 1.4, problem number 10. All right, so we have a quadratic function given here, and we want to restrict the domain so that the quadratic function becomes one-to-one. All right, so let's do that. All right, so if you look at this formula and look at the transformation, so you can see that there's a transformation here. This is going to be it's going to kind of shrink, compress vertically. And then we have -6 at the end. So that's going to be a vertical shifting, shift downward by 6 units. So if you want to sketch the graph of this quadratic function, you're going to have something looks like this. All right, so here's the y-axis and the origin and the x-axis. All right, the original, say, x squared, so parabola would look kind of like this. All right, so this is y equals x squared, right? So by multiplying by 1/2, so it becomes a 1/2 of the original one, so it gets compressed by a factor of 2 in this case. So you're going to have a picture looks kind of like that. Right? Right. So this is after the first transformation. Right. Then second transformation, all it does is just to bring it down 6 units. So you're going to go down 6 units, which will be -6 there. And the graph is going to look kind of like this. Right. So you can see that the graph does not passes the horizontal line test. So we know that it's not one-to-one. So we can either get just the left half of that or right half of it. So the right in the middle would be x equals 0. So you have to split into either -infinity to 0 or 0 to positive infinity. Right? So let's look at the here. Right, so all the choices here looks like the very bottom one, so would be the right restriction. Right, so let's go ahead and check the answer first. Submit for testing. All right, I came back and looks like we got this one correctly. And for the domain selected, so we have the right domain, state the range of the restricted function. All right, so let's look at that. All right, so this is a graph, and even though this might be kind of slow growing, but it's still going to positive infinity. So the lowest value is -6. So range of this function is going to be starting from -6 and then go all the way to positive infinity. Right? So that would be the range. And the domain we chose was -infinity to 0. Right? So let's type it in. All right, so you have -6 all the way to infinity. So we have infinity there. All right, so let's check the answer. Submit for testing. All right, came back and looks like we got the correct range of the function. All right, now it is one-to-one. We can find its inverse function. All right, so let's find the inverse function. All right, so step 1, we're gonna replace f of x by y, right? So y is equal to 1/2 x squared minus 6. All right, step number 2, I'm going to solve for x. So I'm going to say add 6 to both sides. So you have a y plus 6 is equal to 1/2 x squared. Then we're going to multiply both sides by 2 to get 2y plus 6, it's a 12, is equal to x squared. Right? then we're going to take the square root. Right? When you take the square root, we're going to have to consider plus or minus square root of 2y plus 12 is equal to x. Right? But remember that we restrict the domain on the negative side, so we know that we have to use the negative version of that. So we know that we're going to keep this one. Right? Then we're going to have to 3. We're going to swap x and y. So x becomes y is equal to, and square root of 2y becomes 2x and plus 12. All right, last step is we're going to replace y by f inverse. So we have f inverse of x is equal to square root of 2x plus 12. Right? So let's type it in. So we have square root of 2x plus 12. Right? Let's check the answer. Oops, I forgot to put the negative sign. So remember that we have to choose the negative sign here. Right? I think that's the problem. So I'm going to just go ahead and put the negative sign here. Right? And submit for testing. Alright, I came back and looks like we got this one correctly. Alright, so state the domain and the range of f inverse. Alright, so remember that the f inverse is the reverse process of the original function f, and we're switching x and y, right? So domains is basically the collection of x value, and the range the collection of y values. When you swap x and y, the domain, the range are also swapped. So the domain of the original function is going to become the range. So it's going to be negative infinity to 0 is the range. And the domain is the original range, a function of the range of the original function. So it's going to be starting from negative 6 to positive infinity. Right? So we just switch domain and range of the original function. Right? Let's submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.